This is a reduction reaction for forming isobornyl or bornyl from camphor. This is a camphor molecule. These bonds without hydrogens are representing my lone pairs. So in this reaction, camphor is an electrophile that is attacked by a sodium borohydride nucleophile. The sodium cation forms an ionic bond with the borohydride anion. The oxygen on the camphor has a partial negative charge, and the carbon it's bonded to has a partial positive charge. The first step in this reaction is a nucleophilic attack on the carbon. So, hydrogen attacks the carbon that's bonded to the oxygen, and the less stable pi bond breaks, and these electrons go to the oxygen. So one of the hydrides from the sodium borohydride bonds to the carbon, and this forms an alkoxide intermediate. The second step in this reaction is a proton transfer from methanol, which acts as a solvent in this reaction. It's used to stabilize it. Once the bond breaks and the electrons go to the oxygen, it forms a full negative charge on the oxygen. So the proton transfer from the methanol is used to stabilize the negative charge on the oxygen. So the exposed hydrogen from the methanol bonds to the oxygen on the camphor molecule. And then the electrons go to the oxygen on the methanol. This is the isobornyl product that is formed, because if the hydride attacks the carbon from the bottom and places the oxygen on top, it forms isobornyl. But if the hydride was to attack the carbon from the top and place the oxygen on the bottom, the product form would be bornyl. Isobornyl is the major product formed, and both bornyl and isobornyl products are secondary alcohols. And so that the camphor was reduced, the sodium borohydride was the reducing agent, and the hydride was oxidized when it attacked the carbon.